So, who's ready for an epic road trip? We're not just going across state lines or into another country though. We want to travel to a whole new continent. So, we're going from New York City to Paris. What's the problem? It's only around 3,200 miles over the entirety of the Atlantic Ocean. Alright, maybe a west to east trip to another continent isn't possible. But what if we went the other direction? The Bering Strait is all that separates the US state of Alaska from Russia, and at its narrowest point, they're only 51 miles apart. A much more reasonable drive than trying to go from New York to Paris. Oh well, c'est la vie. But unfortunately, there's currently no bridge that crosses the Bering Strait, and there are some very good reasons why. But a crossing between Alaska and Russia isn't impossible. And in the future, the continents of Asia and North America could end up being connected via bridge or even a tunnel. It may seem like there's no real benefit to building a bridge just below the Arctic Circle to connect Russia and Alaska, but a bridge over the Bering Strait could yield some big benefits for countries in both Asia and North America. To start, it currently takes a cargo ship somewhere between 15 and 30 days to cross the Pacific Ocean, depending of course on where it's embarking from and traveling to. But if there was a train line or a highway running from northern Russia across the Bering Strait and down the west coast of North America, theoretically, cargo could be moved much faster than by ocean freighter. But making this dream a reality would require more than just the construction of a bridge. Both the US and Russia would also need to invest in a new, modern infrastructure in order to allow efficient travel, which currently does not exist near where the bridge would be built. Advocates for a bridge uniting Asia and North America argue that this method of freight transportation would be both more economical and safer than the current practice of shipping across the vast and unpredictable Pacific Ocean. Rough estimates suggest that a Bering Strait railway could handle about 3% of global freight, translating into a staggering annual profit of approximately $7 billion. That's more than the GDP of some small countries. Some of the most important cargo that could be moved this way are energy resources such as coal, oil, and natural gas. To put this in perspective, some analysis posit that about 1.5 million barrels of oil could be transported daily from Alberta, Canada to China if a Bering Strait crossing existed, which is like filling 60 Olympic-sized swimming pools with oil every single day. But not everyone is convinced about the benefits a bridge connecting Russia and Alaska would provide. Many experts contend that transporting energy resources or freight via railway and road that doesn't yet exist will cost more in the long run than sticking with freighters. But even they have to concede that transporting goods and cargo over land between Asia and North America could be faster than an ocean journey. Hypothetically, a bridge connecting Russia and Alaska could allow for Arctic fossil fuel reserves and energy resources to be disseminated around the world more easily. But perhaps this is not such a good thing. After all, in order to extract natural resources in the region and build a transportation network to deliver them, large amounts of natural habitat would need to be destroyed, and pollutants would inevitably enter the ecosystem. So building more infrastructure in the region and a connection between Asia and North America might actually do more harm than good. But let's put aside the question of why we should or shouldn't build a bridge between Alaska and Russia and look at the reasons why it has yet to be built. First up are the cold, hard realities of logistics and geology. The distance between Russia and Alaska is about 51.3 miles. In order to construct a bridge that could extend between the two continents, the Diomede Islands would need to serve as a contact point. The Diomedes are a pair of small islands almost exactly in the middle of the Bering Strait. Big Diomede, as you probably guessed, is the larger of the two and is controlled by Russia, while the eastern Little Diomede is US soil. The two islands are just 2.4 miles apart, but since the international dateline runs directly between them, Big Diomede is actually 20 to 21 hours ahead of the little one, depending on the time of year, which has led to the islands being given the nicknames Tomorrow and Yesterday Island. Since creating a bridge to traverse the entire strait would be an almost impossible engineering feat, the bridge would need to be broken into three parts. The first would connect from the easternmost point of Russia and travel nearly 22 miles to Big Diomede. The second part of the bridge would travel less than 2.5 miles to Little Diomede, and the final section would run from Little Diomede to Wales, Alaska, which is another 24 miles. Some sections would be easier to complete than others, but it's the long distances between the Diomedes and the mainland that pose the biggest problems. First of all, the waters average 98 to 164 feet deep. These depths aren't impossible to work with, but some parts of the strait reach 295 feet deep. Since the bridge would need to withstand a massive amount of weight from freight trains or trucks passing over it, the causeway would need to be supported by multiple concrete pillars anchored to the seafloor. It is worth noting that while the tides and currents in the area are strong, they're not as intense as in some regions where bridges have been built before. This would make working in the area manageable as long as the workers were protected from the elements, such as extremely cold and deadly temperatures. Since the Bering Strait sits just south of the Arctic Circle, the amount of daylight the region receives during the winter months is greatly reduced, meaning that work hours would need to be dialed back for around half the year. During these dark months, the temperatures average -4 degrees Fahrenheit, but can reach as low as -58 degrees Fahrenheit. During the months of May through September, there is sunlight for most of the day, and the temperatures are much more manageable. But the construction phase would end up taking even longer than the average bridge project due to the fact that it would be a stop-and-go process as the seasons change. The extreme cold, high winds, and salty waves would corrode and damage the steel and other metals used to build the bridge. This means that most of the structure would need to be covered almost completely in concrete. But once the bridge is technically finished, the work would be far from over. The bridge's location means that it would also require constant maintenance to ensure it is not compromised by hazardous conditions. This would add to the cost of the project and would mean the bridge would need to be shut down periodically for repairs. Then there are the ice floes in the Bering Strait. They can often be 6 feet thick and are constantly carried through the waters by the currents. These chunks of ice could cause massive damage to the ships working to construct the bridge as well as the support pylons of the structure itself, since the ice floes can be incredibly powerful. It's estimated that a large ice floe could produce 9,900,000 pounds force in some circumstances. This could cause a catastrophic failure of the bridge supports if they are not built and maintained properly. So, it's clear that the environment itself makes building a bridge across the Bering Strait extremely difficult. However, it would not be impossible. So, what else has stood in the way? You might be surprised to learn that it's actually the economics that have largely held the bridge back. The trade of goods and materials between North America and Asia is incredibly lucrative, and there are numerous systems already in place to transport goods from one continent to the other. This is mostly done by cargo ships that can carry massive amounts of goods. Just to put things into perspective, the U.S. goods and services trade with Russia was around $34.9 billion in 2019. Not all of this trade was done across the Pacific, but a large percentage of it was. However, it is the amount of commerce done with China that really brings into question whether a bridge across the Bering Strait would be lucrative or not. U.S. goods and services trade with China totaled approximately $615.2 billion in 2020. The enormous amount of business happening between the two countries might make a bridge connecting Asia and North America worth it. But only if the construction costs associated with the bridge and infrastructure connecting it to major hubs make sense. And when the numbers are analyzed, the expenditures of the project are a big deterrent, and one of the main reasons why there is no bridge between Russia and Alaska. It's important to note a lot more roads and railways than just a single structure across the Bering Strait will need to be built in order to connect the two countries. In the United States alone, 750 miles or 1,200 kilometers of roads and railways need to be built just to connect the bridge to the closest major road system running through Alaska. A similar highway to what is needed has been proposed by the Alaskan government in the past and was estimated to cost between $2.3 and $2.7 billion. That works out to be around $5 million per mile of infrastructure. And that would be the easiest and cheapest part. The road and rails that need to be constructed on the Russian side of the bridge would cost much more, as the infrastructure in the Chukotka Autonomous Region is practically non-existent. In fact, there are no railways within 2,000 miles of the strait. The closest road is the M56 Kolyma Highway, which is approximately 1,200 miles from the Bering Strait. And to make matters even worse, it's unpaved. So lots of infrastructure would be needed, otherwise you'd end up with a bridge with nowhere to go on the other side. Truly a bridge to nowhere. And this doesn't even consider the fact that in order for this route to make any economic sense, the roads and railways leading to the Bering Strait would need to connect to major cities in Russia and China. The extent of the construction project in Asia to get goods up to the Bering Strait crossing would be astronomical. And since so much trade is already conducted through cargo ships, you can be sure that they would be lobbying all involved governments hard and reminding them of just what a costly endeavor this would be. So we're talking many, probably tens of billions of dollars in infrastructure costs. And that's before we even get to the cost of building the bridge itself. But more on that in a moment, since first we need to talk about the political problems, and specifically one very, very big one. A bridge connecting Russia and Alaska has been discussed many times, but thanks to Vladimir Putin's war in Ukraine, all collaborative projects between the United States and Russia are currently off the table. The only way that a bridge crossing the Bering Strait could be possible at this point in time is if China took care of all the components of the project in Asia. However, even then, the diplomatic relationship between the United States and China isn't the greatest right now either. And neither the United States nor Russia, nor even China could do this on their own. There must be collaboration and cooperation if a bridge connecting Russia and Alaska is ever going to come to fruition. One simple but very real example of the problems that all governments involved would need to agree on is a single-track gauge for the railway that would utilize the bridge. The US, Canada, China, and South Korea use a standard gauge of 1,435 millimeters, while Russia uses a 1,520 millimeter gauge. It would make little sense for trains in Asia to reach the Bering Strait and then offload all of their cargo onto another set of train cars with a different gauge so that they could then continue over the bridge and into North America. The most viable option is to build tracks using the standard 1,435 millimeter gauge. But convincing Putin and the Russian leadership to do so is likely an insurmountable task. So even something as minimal as agreeing on gauge type is an issue holding up the bridge. And then there's the issue of parks and other protected lands. The lands on either side of the Bering Strait are an important part of prehistoric and human history, and are considered protected lands by both Russia and the United States. What this means is that any construction project or bridge needs to take into consideration ways to reduce the impact and damage done to the surrounding area. This includes not only archaeological and paleontological sites, but lands of indigenous people who have resided in the region for thousands and thousands of years. Any construction project running through the native Alaskan lands must be done through the consultation of the indigenous peoples of the region. However, it is rare that industries and corporations conduct themselves in ethical ways when working in or around protected land, so the indigenous people would likely be very wary of any promises made. But even if a minimal environmental impact was somehow agreed upon, habitat would be lost. It's simply impossible not to destroy some natural habitats when dealing with a construction project of this scale. This has led many to suggest that it is not just the economic cost that makes a bridge connecting Alaska to Russia untenable, but the environmental cost is so great that it would be better to just leave the lands around the Bering Strait alone. Despite all of those obstacles, there's an incredible history of humans attempting to cross the Bering Strait. And even more surprising is that even though the United States and much of the Western world are waging an economic war against Russia using sanctions, there are still a few proposals floating around to connect Asia and North America. Interestingly, a bridge has actually existed between Alaska and Russia. Well, a land bridge, that is. As recently as 16,500 years ago, the Bering Land Bridge sat where the Bering Strait is today. And this passage is likely one of the several ways that humans reached the Americas. The connection between the continents was the result of lower sea levels during the Ice Age. At this time, large amounts of seawater was trapped in glaciers, with some of them being as much as 2.5 miles thick in some parts of the northern hemisphere. Scientists hypothesized that the climate along the land bridge connecting the two continents was likely dry and covered in minimal ice. It also had an abundant amount of cold-hardy tundra vegetation, allowing animals such as woolly mammoths to migrate into the Americas. It is possible that humans followed these migration herds, and that is how some indigenous population ended up in the subarctic and northern sections of the Americas. Recent evidence suggests that humans crossed over the Bering Land Bridge as early as 30,000 BCE. But then, somewhere between 10,000 and 11,000 years ago, the planet's temperature began to warm, and the glaciers started to melt, resulting in the Bering Land Bridge becoming submerged underwater. It wouldn't be until the 19th century that traveling across the Bering Strait without the use of boats would become part of human history once again. In 1846, Colorado Territorial Governor William Gilpin raised funds to conduct a viability study for building a railway along the Alaskan shores and up to the Bering Strait. Gilpin had plans for much more than just Alaska, and in the decades to come, he would spread word of his vision to create a cosmopolitan railway, linking the entire world using a series of railways. In 1859, Russia desperately needed funds after losing the Crimean War to France and Britain. The Russian leadership considered selling Alaska to the United States in order to fuel its economy after their failed war. However, it wouldn't be for another 8 years before the United States finally purchased the rights to Alaska, then known as Russian America. The final selling price was $7.2 million, or roughly 2 cents per acre. On October 18, 1867, Russia officially transferred the Alaskan territory to the United States. For the next 92 years, Alaska would be a territory of the U.S., but would not be given statehood until the following century. However, the purchasing of Alaska opened the door to projects led by U.S. companies and entrepreneurs, including those focused on building a bridge across the Bering Strait. In 1892, Joseph Strauss, who would go on to design over 400 bridges along with serving as a project engineer for the Golden Gate Bridge, created the first proposal for a Bering Strait rail crossing as his senior thesis. Nothing would ever come of the design envisioned by the young engineer, but showed that Gilpin's Cosmopolitan Railway could theoretically be possible in the future. The linchpin in Gilpin's whole plan was that there needed to be a way to get trains across the Bering Strait, and once this problem was solved, everything else would fall into place. This was as long as he could secure the funding and find backers, which of course, he never did. In 1904, a group of railroad magnates came up with a proposal to create a Siberian-Alaskan railroad. They envisioned the train traveling from Cape Prince of Wales in Alaska, across the Bering Strait, and into Russia. However, this group of businessmen did not want to build a bridge over the Bering Strait, but instead construct a tunnel underneath its waters to carry passengers and freight from North America to Asia and back again. The project would need an additional 3,100 miles of rails through Russia and 1,900 miles of rails in North America to connect major cities to the tunnel near the top of the world. But the businessmen wanted more than just the railroad rights. They also included the mineral rights for 8 miles on each side of the railway in their proposal. Their lease would be for 90 years with the ability to renew in the future. After reviewing the proposal, the United States government decided not to move forward with the project. Tsar Nicholas II, on the other hand, approved the American proposal but made it clear that the Russian government would not finance the project. The railroad magnates determined that the whole thing would cost over $350 million at the time, which is about $12 billion today. However, it seemed like the project could get underway with the Russian Tsar's blessing, and a connection across the Bering Strait would finally be built. Unfortunately, the Russian Revolution broke out in 1905. World War I began 9 years after that, and all funding and interest in the project to connect Alaska to Russia were forgotten as the world descended into chaos. On June 30th, 1958, the U.S. Senate passed the Alaska Statehood Bill, and on August 26th, a special election was held in Alaska to vote on statehood, which passed with a margin of 6-1. On January 3, 1959, Alaska officially became the 49th state in the U.S., and now that Alaska was formally recognized as a state, more funds and federal aid could be secured for infrastructure projects such as building roads, railways, and bridges. Around the same time in 1958, engineer Tung-Yen Lin came up with his own plans to build a bridge across the Bering Strait. His goal was to foster commerce and understanding between the people of the United States and the Soviet Union. But neither government had any interest in settling their differences at the time, so in 1968, Tung-Yen Lin started the nonprofit Intercontinental Peace Bridge, Inc. The company conducted a feasibility study and determined that it would be possible to connect Alaska and Russia via a bridge for around $1 billion. Nothing came of the plans, but the Intercontinental Peace Bridge did not die quite yet. In 1994, Tung-Yen Lin did another expenditure analysis and determined the bridge would now cost $4 billion. But of course, this cost did not include all of the additional infrastructure that would need to be built to connect the bridge to major cities in North America and Asia. Tung-Yen Lin continued to argue that if Russia and the United States could put aside their differences, they could build a bridge over the Bering Strait that would both literally and metaphorically bring them closer together. However, neither government was interested in working with the other, and Tung-Yen Lin's dream of a peace bridge never came to fruition. In 2006, a new feasibility study was sponsored by the Canadian Arctic Railway Company that resulted in a 2,326-page report which concluded that a tunnel under the Bering Strait was not only the better way to create a crossing, but would be more economical. Unfortunately, the company went bankrupt not too long after the study was completed, so maybe their estimates should be taken with a grain of salt. In 2009, though, the governor of Alaska, Sarah Palin, ordered her own study analyzing the costs of constructing railways through the state all the way up to the Bering Strait. This project wouldn't necessarily be to create a crossing into Russia, but would allow Alaska to ship energy resources and fresh water to the rest of the country in times of need. The breakdown of the project came back, stating it would cost $3 billion to complete, and all plans were immediately thrown in the trash. In May of 2014, the Beijing Times reported a high-speed rail project that was in the works. The proposed project would build a 6,200-mile or 10,000-kilometer high-speed rail from northern China to the United States. Like with the other more modern plans, the passing from Russia to Alaska would be done via tunnel and not a bridge. The high-speed train would then travel from Wales, Alaska to Fairbanks and follow the Alaskan Highway all the way to Alberta, Canada, where several routes could then be taken to enter the United States. As with every other project, though, this one failed to get off the ground because of the disinterest of governments working together. Not everyone has given up on the Bering Strait crossing. As of yet, no one has been able to convince the United States or Russia that a bridge or tunnel between their two nations is something the world needs, but China is looking into ways to connect Asia and North America via a railway or road system. There is even speculation that part of China's Belt and Road Initiative may someday include a Bering Strait rail crossing in order to move more energy resources and goods between Canada and China. But with the way the geopolitical climate is right now, it doesn't look likely that a connection will happen anytime soon. But that won't stop people from trying, and there continues to be real plans made for a Bering Strait crossing, with some truly eye-watering price tags associated with them. But while it might be expensive, there have been similar in scope projects completed around the world, so maybe a bridge between Russia and Alaska isn't as impossible as history has made it seem. On August 30th, 1956, the Lake Pontchartrain Causeway opened. It stretched 24 miles across Lake Pontchartrain, connecting the urban areas around New Orleans to the smaller communities along with the North Shore, and is the longest bridge to extend over water in the world. It used 9,500 concrete pilings to create a sturdy structure that could handle large amounts of traffic, including tractor trailers carrying goods and cargo. Why this is important for the Bering Strait crossing is that since any bridge built to connect Alaska and Russia would utilize the Diomede Islands, none of the stretches of the bridge would need to be longer than the Lake Pontchartrain Causeway. This means that the length is not the problem when constructing a bridge over the Bering Strait. It's been concluded by recent studies that a bridge and accompanying infrastructure to connect the continental United States and China using highways, electrified double-tracked high-speed rails, and pipelines would cost around $105 billion. This would be 5 times what it cost to build the channel that connects the UK to mainland Europe. However, proponents of a land route between North America and Asia note that just the petroleum resources that could be transported between the continents could be worth trillions of dollars. And maybe the different rail gauge sizes aren't such a problem after all. To solve the rail gauge problem, it has been shown that technology has advanced to the point where unloading and reloading cargo between different trains can be done in a surprisingly quick manner. It is now possible to transfer the contents of a 60-container train in 1 hour. This means that neither Russia nor the United States would actually need to change their railways, resulting in one less obstacle standing in the way of a bridge connecting the two countries. And if this doesn't satisfy all parties, there are now variable gauge axles for locomotives in use around the world that allow the gauge of the train to be changed. And these developments have led to some very serious modern plans for a crossing. In 2007, the TKM World Link, also known as the ICL World Link, was proposed. The railway would be 3,700 miles long and connect Siberia to Alaska, with the goal of carrying oil, natural gas, and passengers between Russia and the United States. The plans called for a 64-mile tunnel between Russia and Alaska, which would be the longest in the world, beating the 37-mile Guangzhou Metro Tunnel in China by 27 miles. The tunnel itself was estimated to cost between $10 billion and $12 billion, with the final price tag of the entire project estimated to be around $65 billion. When Vladimir Putin approved the development plan in 2008, the project was slated to take over 20 years to finish, with a tentative completion date of 2030. No construction was conducted anywhere near the Bering Strait, but it did show there was a renewed interest in a crossing, at least on the Russian side. In 2014, China started a proposal for a US, Canada, Russia, China bullet train route that would cross over the Bering Strait. The train would reach speeds of 220 miles per hour. Just like the World Link, these plans didn't call for a bridge over the Bering Strait, but a tunnel under its frigid waters that would be about 120 miles long. Unlike previous proposals, the focus of this high-speed rail would be on carrying passengers between the two continents and would allow for people to go from the continental United States to China in approximately 2 days. But this raises the most important question: why? If travelers are looking for fast ways to get between Asia and Russia, an airplane can make the journey from Beijing to New York City in 14 hours and 55 minutes. This very fact renders a passenger train that crosses the Bering Strait pointless. A passenger train between Asia and North America just isn't practical. And this is why most believe nothing will ever come of the proposed railway and tunnel under the Bering Strait. But then in 2015, a new collaboration emerged that went back to the bridge connection between Russia and Alaska, when China and Russia began collaborating on the Trans-Eurasian Belt development, which would run across much of Siberia. A key component of the plan included a road bridge over the Bering Strait that would also incorporate gas and oil pipelines that would carry resources from Siberia and Alaska into China. It was even suggested that later iterations of the project would include a high-speed rail and superhighway that would connect London to New York City via Russia. When Vladimir Yakunin, the head of Russian railways, unveiled the plans for the infrastructure project that would allow such a transportation system to be developed, many around the world dismissed it altogether. Most agree that a railway and road system could be built between Asia and North America, and that the bridge over the Bering Strait was possible, but the whole project just didn't make sense. Even when the plans were revised to include an underwater tunnel instead of a bridge, the international community had a hard time understanding what the point would be other than spending huge sums of money, resources, and time on a project that would yield only minimal benefits. To be fair, if Russia could get other nations on board, the Trans-Eurasian Belt development would create millions of jobs, and if completed, the road and railway would be utilized to carry passengers and cargo across Europe, Asia, and North America. So Russia and China would both benefit from the undertaking. but the benefits as a whole never seemed to outweigh the exuberant costs. It was estimated that around 12,500 miles of new roads and railways would need to be built. The tunnel under the Bering Strait would cost somewhere between $25 and $50 billion, and the entire project would require at least $1.5 trillion in initial costs. But many agree this figure is much, much too low, especially when factoring in the challenges workers face in rural areas and the extreme climate just below the Arctic Circle. So for now, there is no bridge connecting Russia and Alaska. Even though there have been numerous studies and proposals conducted on building a connection via bridge or tunnel across the Bering Strait, it seems unlikely that a structure will be started anytime soon, since for most countries and corporations, the cons simply outweigh the benefits. There's too much infrastructure that needs to be created to make a link between Asia and North America practical. The economic benefits are there, but they just aren't enough to justify pouring hundreds of billions or even trillions of dollars into such a project. In the future, if governments could put aside their differences, transportation technology advances tremendously, and there is a sustainable way to construct all of the infrastructure needed to cross the Bering Strait and proceed to major cities in Asia and North America, perhaps a new proposal will be accepted to build a bridge connecting Russia and Alaska, since where there is a will, there is always a way. But for the time being, it's much more likely that travel by plane and moving goods by cargo ship will continue to be the norm between Asia and North America.